Find the indefinite integral of x ln x squared dx, hence show that the definite integral of x ln x squared dx with an upper boundary of 4 and the lower boundary of 1 is equal to 32 ln 2 squared minus 16 ln 2 plus 15 over 4. Okay, so for a, we have to start off with integration by substitution. So this means that we have to select our u. So our u here would be ln x, and in this case, we can turn this into x equals to e power u, and then this allows us to get dx equals to e power u du. Now we have all of these u values, which we can use to substitute into this. And here, now we just get x is e power u, and ln x is u squared, and then dx is e power u du. Remember, all of it is from here, okay? And here we get u squared times e power 2u du, and here we can start our integration by parts. If you don't know how to do this, I can leave a link in the description, which goes more in detail on how you actually do this. Okay, so for this, it would be u squared, and this one would be e power 2u. And differentiating this even more, it equals 2u, 2, and 0. And here it is e power 2u, 1 over 2 e power 2u, 1 over 4 e power 2u, and 1 over 8 e power 2u. And we look at our diagonals here. And for our first one, we have u squared, so half of u squared e power 2u. And our next one would be minus 1 over 2 u e power 2u, and our next one would be a plus 1 over 4 e power 2u, and don't forget your plus c. So our indefinite integral of x ln x squared dx is equal to 1 over 2, and let's bring this back to the x world, right? So we have our x's, have our x values, and we put this in here. And for this, 1 over 2 u squared, our u squared will be ln x squared, and our e power 2u, keep this in mind, okay? Since our x is equal to e power u, our x squared would be e power 2u, as it would be e u squared, which is the same thing as e power u times e power u, which in this case, you just add the exponents together. All right, so therefore we get e power 2u here. And so we add x squared minus 1 over 2 ln x. Here, e power 2u is x squared plus 1 over 4 x squared plus c. And this would be our answer for part A. For part B, we need to show that this definite integral is equal to this. Okay, so this is a lot easier. That's why it's only 3 marks, because we already have our indefinite integral of x ln x squared. Now we just have to have our upper and lower boundary. Okay, so 4 and 1, so this here, to open our bracket, 1 over 2 ln x squared minus 1 over 2 ln x squared plus 1 over 4 x squared, and close this. So we would have 1 over 2 ln 4 squared minus 1 over 2 ln 4 squared plus 1 over 4 squared. And from here, we minus it with the lower boundary. Now what we begin to notice is that we would be substituting 1 into our ln x, but ln1 is actually equal to 0. So this would be 0, this would be 0, and we would be left with this. So we would only need to be subtracting from that, which is 1 over 4 1 squared. And here, so let me just scroll down, we would be left with 1 over 2 ln 4 squared times 16, 1 over 2 ln 4 16 plus 1 over 4 16 minus 1 over 4. So here, keep in mind that log a power b is same as b log a. Okay, so that's what we're going to be doing here, because if you look up, we need to turn this into a 2, right? So we can just do this. Actually, we can just combine this with this. Half of 16 is 8, so here 2 ln 2 squared minus half of 16 again is 8. And we do the logarithm rule here, plus 16 over 4, which is 4, minus 1 over 4, that is 15 over 4. And here, remember that this 2 ln 2 is the same thing as 2 ln 2 this way. Okay, so when we're trying to take this out, we're trying to take the 2 out, it would be 2 squared ln 2 squared. Okay, so now that we know that, we can take this out, and it would be 2 squared, which is 4, and ln 2 squared minus 8. Since there's no exponent here, we just need to do that. 16 ln 2 plus 15 over 4. After that, we just do 8 times 4, which is 32 ln 2 squared minus 16 ln 2 plus 15 over 4. And this should match the 32 ln 2 squared minus 16 ln 2 plus 15 over 4.